Hi folks, and welcome back to the channel. In this series I'm going to take you through some of the basics of pandas and the most commonly used functions. I'm going to change how we usually do these videos. I'm going to provide a bit of theory first before we have a look at the coding examples. Hopefully this will improve the quality of your learning, so let me know in the comments below if you think this works better. So what actually is Pandas? Pandas is a Python library used mostly for data analysis. So you can install Pandas usually via pip. I like to think of Pandas as a Microsoft Excel of Python, where we can generate some of the same outcomes programmatically. Also allows you to get your data in a tabular format for cleaning, modification and analysis. For this course I'm going to assume you've got a basic understanding of Python, but looking to dabble into the world of Pandas. Okay, that's the intro out of the way, let's get started. So we're going to start off this series by looking at 6 functions which are centred around the creation and shaping of a Pandas data frame. So we'll look at how to create a data frame, how to join data frames together, how to sort a data frame on a column, how to drop a column, how to rename a column, and finally how to sort a data frame on its index and resetting of a data frame index. So what actually is a Pandas data frame? A data frame is a table stored in memory. You can sort of visualise it like a Microsoft Excel spreadsheet. You can create a new data frame using the pd.dataframe function, and there are a few mechanisms of passing data into this data frame. One method of passing in data is using a Python dictionary where the keys are the column names and the values is a Python list of values. And another method is using a two-dimensional list where we pass in the column names and the columns parameter. Another way of creating a Pandas data frame is through the reading of CSV or Microsoft Excel files. Now this is probably the most common way of creating a data frame using Pandas. Typically you would want to read in a CSV and perform a variety of functions on it. This is quite common in data visualization and data engineering. So to create a data frame using a CSV, all you have to do is pass in the path to a file. If your file is not comma separated, you can also pass in a custom delimiter, such as a tab or semicolon. Headers are usually inferred from the first row, but you can also pass in your own custom headers through a combination of the header and names parameter. Another functionality of the Pandas data frame is that we can concatenate 2 or more data frames together. To do this, we just pass in an array or a Python list of data frames to the concat function, and this will stack the data frames on top of one another. We can also join the data frames side by side using the axis equals 1 parameter. We're also able to sort the values in the columns using the df.sortValues function. Or if we want to sort multiple columns, then we can pass in a list of strings. Data will be sorted in ascending order unless specified through the use of the ascending equals false parameter. We can also drop columns in a data frame using the df.drop function. So to delete a singular column, all we have to do is pass in a string with the column name using the columns param. Or if we want to delete multiple columns, we can pass in a Python list. We can also rename existing columns in a data frame using the df.rename function. To rename a column, you'd pass in a Python dictionary. The key would be the existing column name and the value would be the new column name. Don't forget that we can always rename columns when we create a data frame too. You will notice that when we concatenate data frames, indexes from the original data frames will be kept. Now this causes problems when we try and select rows using the index. For example, selecting index 1 could potentially return us 2 results. So we can use the reset index to generate a new index. The reset index will copy the existing index into a column, however we can stop this behaviour by using the drop parameter. Just like sorting a column, we can also sort back on the index. And like most Pandas functions, we can sort in place, meaning that we don't need to assign the new data frame, the new sorted data frame to a new variable. Okay, so that's the theory out of the way. So let's jump into a Jupyter notebook and I'll walk you through some of the examples and implementation of these functions. Okay, that's me in a Jupyter notebook now. So the first thing I'm going to do is import pandas as PD. So to replicate this tutorial yourself, you're going to have to make sure that you've installed pandas via pip. So I'll just run this cell. Okay, in the theory part, I spoke about the multiple ways that you can create a pandas data frame. And in this cell example, we're going to have a look at the Python dictionary method. So we can see here that we have our columns as the keys and the values as a Python list here. So this is the key, this is the values. We have column B, column C. So if I'll just run the cell, you'll see the output. So we can see column A here matches to these values, column B here matches to these values, and column C here matches to these values. The method of creating a pandas data frame is using a two-dimensional list. So if we have a look here in this cell, we have a list here which encapsulates a selection of other lists here. And the way to think of this is we have column A here, column B here, and column C here. And we can define our column headers using the columns param and passing in a list of strings. So I'll go ahead and run the cell and show you the output. So column A here has 147, column B here has 256, and column C, which is defined here, has 3, 6 and 9. Another way of creating a data frame is by reading a CSV file, and this is probably the most commonly used function of pandas. So I'll just go ahead and run this cell and show you the output. Now we can also go ahead and change the column names of our CSV file by passing in a few more parameters. So I'll just go ahead and uncomment this code. In this example here, we're setting the header to equal 0 and passing in a new list of columns. So we can see how this data frame changes. So that this data frame previously had the values of this read CSV example file, but we've passed in a new set of headers. Similar to CSV files, we can also read Excel files as well using the pd.readExcel function. The function works in a similar way to read CSV, where we pass in the file path as a string. Okay, let me show you the output to this. Now, similar to CSV, we can also pass in a set of custom headers using the same mechanism as above. So let me just uncomment this code here. And we can see we're setting the header to equal 0 again and passing in a list of strings as a new column names. So just watch the column names here as they change. So values have stayed the same, but the column headers have changed. The next code example we've got here is the concatenation of two data frames, and we're going to look at this as a vertical example, so stacking data frames on top of one another. So to do this, like I explained in the theory, we just call the concat function and pass in a list of data frames. So for this example, I've created one data frame here, df1, I've created another data frame here, df2, this is getting passed in as a list. So let me just go ahead and show you the output for this. So we can see that our data frames are now stacked on top of each other. So I've got another concatenation example here, but this time I've mismatched the columns. So rather than having column A, column B, column C, and column A, column B, column C, I've created column D, E and F in this one, and I'm just going to show you what happens here when we concatenate these. So it's kind of like an outer join if you're familiar with SQL. So what's happened here is the rows have been appended on, but we've also created these new columns in here as well. Now sometimes we don't want to stack the data frames vertically when we concatenate, but you can also concatenate horizontally as well. And we can do this by passing in another parameter, axis equals 1. So if I just run this and show you the output. So we can see rather than column A, B and C being appended down here, it's been appended onto the right hand side of the data frame. So another useful function of the Pandas data frame is having the ability to sort the columns. So in this example here, I've created a small age and height data frame. So we can see that the age here is not in any particular order, but we can go ahead and sort this in ascending order by using the sort values function. Now remember, sorting values by default is always ascending. So if you wish to get the values sorted on descending order, you would just pass in the ascending equals false parameter. This example here. And you can see that our height is now in descending order. Pandas also gives us the ability to drop and rename columns. So I've created another data frame here. We have old column, del column, and a list of values here. So what I'm going to do in the first example is drop the column del column. So we can see this is no longer in the data frame. And in this example here, we're going to use the rename column. So to rename, if we remember from the theory, we pass in a dictionary, the key being the old column name and the value being the new column name. So I'll just go ahead and run this cell. And you can see the old column has now been renamed to new column. So when we concatenate data frames, the existing indexes are always kept. So let's have a look at this small concatenation example. And we can see here that the indexes from both data frames are kept. Now this might cause us a problem when we try and search for data based on the index. So if I just comment out this example here, so we can see this returned 2 results because it has 2 1s in the index. Now to fix this problem, we can reset the index by using the reset index function on the data frame. So let me just run this cell here with the reset index, and you can see that the index has now changed from 0, 1, 2, 0, 1, 2 to 0, 1, 2, 3, 4, 5. We can compare again to the first example. Just comment this code out. And there we have it, 0, 1, 2, 0, 1, 2. And now it's 0, 1, 2, 3, 4, 5. One of the things that happens when you reset an index is that the index gets moved to a new column, and sometimes you don't wish to have that functionality. However, we can stop it using the drop equals true parameter. So if we reset that existing index again and pass in that parameter, you'll see that that index column is no longer there in this data frame. Finally, as well as sorting columns, you can also sort on indexes as well. In this example, I've created 2 data frames and I've specified an index to the data frames. Rather than inferring an index, I've explicitly told the data frame what index it should have. So if I just quickly comment this code out here, run this. So we can see the index isn't in ascending order. Now we can change this by just simply running the sort index function. and you can see that this has moved the index back into ascending order. Okay, so that's some of the basic functionality in creating and shaping a data frame. Be sure to hit the thumbs up button and subscribe to keep up to date with the next parts of this Pandas series.